So for the last few examples for the notes from section 8.5, we're going to take a look at shifting tangent, cotangent, secant, and cosecant horizontally, so left or right. So we take a look at this first example here. We want to graph two periods of tangent of x minus pi over 3. So tangent of x minus pi over 3 is going to be a shift of the tangent function to the right, pi over 3. So the way I'm going to approach this is I'm going to graph tangent of x, and then I'm going to just take that function and just shift it to the right, pi over 3. Similar to how we graphed sine and cosine, shifting them left and right, I'm going to do a similar process here. So tangent of x has a period of pi. So if I look at the x-axis, I'm going to break that up into two periods, 4 tick marks from 0 to pi, and then from pi to 2 pi. Now the only thing that I'm going to do differently is, if you remember, that tangent of x is technically centered on the y-axis, that part of the function will be to the left and go through 0, 0, and part to the right. I'm going to keep that in mind when I graph tangent of x minus pi over 3. So draw my vertical asymptotes at pi over 2 and 3 pi over 2. And then I'm going to graph the part to the left of the y-axis as well, which will be a vertical asymptote at negative pi over 2. And then my y-axis I'm going to break into show 1 and negative 1. And then here's tangent of x, and I'm going to draw it in red, and I'm going to draw it dotted because it's just the function I'm going to use to shift. So there is two periods of tangent of x. What I want to do is I'm just going to identify the x values in between here. So pi over 4, 3 pi over 4, 5 pi over 4, and 3 pi over 2. And now, if I think about how this, I'm going to erase the vertical asymptotes first. I just don't want the graph to get too cluttered with everything that's going on. Now, if I think about how I have my x-axis broken up, I have every other box is pi over 4, and if I want to shift to the right pi over 3, that's going to be slightly more than pi over 4. So if you look at the point 0, 0, I'm going to shift that to the right just more than pi over 4, and then pi over 4, 1, I'm going to shift that just to the right, pi over 3, excuse me. So if you take a look at that first part of the tangent function in red that I drew, those 3 purple dots represent the 3 dots that were on tangent of x, just shifted to the right, pi over 3. And then where my vertical asymptote goes is somewhere between 3 pi over 4 and pi, and I'll identify that x value here in a second. But I'm just shifting everything from that first period of tangent that I drew to the right, pi over 3. Now the part that could be potentially frustrating is it's not going to land on a perfect box on the x-axis, just because I broke up my x-axis according to my period, and my shift of pi over 3 is not, pi over 4 or pi over 2 or anything nice related to my x-axis, which is okay. So it's going to be somewhere, it's going to be an approximation. So there would be my first period of my function that I'm trying to graph, and I'll connect those and draw the rest of the shape here in a second. Now in terms of the second period, that vertical asymptote will shift from 3 pi over 2 to the right, pi over 3, and then I would shift the 3 points from that second period of tangent in red that I drew. And then if I connect them, here's what the function I have looks like. Looks like that. And then if I want to identify those vertical asymptotes, it was at pi over 2, and then it shifted to the right, pi over 3. So pi over 2 plus pi over 3 is actually 5 pi over 6. So that vertical asymptote is going to be at 5 pi over 6. The asymptote that was at negative pi over 2 shifted to the right will be at negative pi over 6. And then the asymptote that was at 3 pi over 2 shifted to the right will be at 11 pi over 6. And one quick way to verify that your asymptotes are in the right place is the distance between them should be pi, which from negative pi over 6 to 5 pi over 6 is pi, and from 5 pi over 6 to 11 pi over 6 is pi. So if you look at the purple graph that I have drawn and the purple asymptotes I have, that is my shifted tangent function to the right, pi over 3. And then if I want to identify some information about it, the x-intercepts will occur, instead of 0, 0 is now pi over 3, comma 0. That's the first one in my first period. And then instead of at pi, it'll be at 4 pi over 3, 0. So those are my x-intercepts. And then my vertical asymptotes will be, like at the values I just identified, negative pi over 6, 5 pi over 6, and 11 pi over 6. So the process I'm going to use in general for tangent and cotangent is graph tangent and then shift that tangent function to the right pi over 3. And then for the second example here, I have this cotangent function here that I want to graph. So I'm going to graph negative cotangent of x. Pay attention to the negative. What that's going to do is essentially reflect my function over the x-axis, which will make it look a lot like tangent of x, because cotangent and tangent are a phase shift of one another and also a reflection. So the period of cotangent of x is pi. The way I want to break up my x-axis would be 4 marks to pi and 4 more to 2 pi. And then the vertical asymptotes for cotangent actually occur at 0, pi, and 2 pi. So this is my cotangent function that I'm drawing here in red. I'm going to identify the values in between 0 and pi, because right in the middle is where cotangent should cross the x-axis. So if I want to continue drawing the shape of negative cotangent of x, it's actually going to look like tangent of x. The only difference is where the vertical asymptotes occur, and instead of going down from left to right, the reflection, that negative out front, is going to make the function be bounded by the vertical asymptote at 0 and go up through those 3 coordinates that I have there. And then if I draw the second period of negative cotangent of x, it would look like that. Now what I want to do is take that function and shift it to the right pi over 4. So I'm going to erase the vertical asymptotes I have just to kind of clean up the graph a little bit. And then I'm going to shift my vertical asymptote from 0 to pi over 4, which works out nicely in this case because pi over 4 is actually 1 tick mark on my x-axis, because I was counting by pi over 4s. So I'm drawing a vertical asymptote there at pi over 4, vertical asymptote in between pi and 3 pi over 2, which is at 5 pi over 4, and then a vertical asymptote to the right of 2 pi, which is at 9 pi over 4. So those are my 3 vertical asymptotes, and that's just a shift of my graph that was in red. So I'm going to shift every other point in that first period to the right 2 boxes, which in this case is pi over 4. I'm going to shift all the points, those 3 points in the second period, to the right pi over 4 as well, which is 2 boxes. And that purple graph there with those purple vertical asymptotes is the graph that I was asked to draw. So if I want to identify some information about it, the x-intercepts will be at, which were at pi over 2 and 3 pi over 2. They're actually shifted pi over 4 units to the right as well, which will put them at negative pi over 4. I just drew 1. You can see that to the left of the x-axis. If I wanted to, you're not specifically asked to do that. You could just keep those 2 periods there that I had in purple originally. So if I identify the x-intercepts of all 3 of those pieces, they'd be at negative pi over 4, 0, 3 pi over 4, 0, and 7 pi over 4, 0. So those are my 3 x-intercepts. And then in terms of my asymptotes, they would be at pi over 4, 5 pi over 4, and 9 pi over 4. This function will actually have a y-intercept. If I drew a third period, if I would have kept the first 2 periods that I had there, this function would cross the y-axis, but it wouldn't be visible. That's one of the major reasons why I drew that third one, is so I could actually identify that y-intercept, which would be at 0, 1. And there's that shifted cotangent function. So the negative reflects it over the x-axis. So the red function was cotangent of x, and then I just shifted that to the right pi over 4, and there's the function that I'm looking for. For the third example, we're going to be looking at cosecant of x shifted to the right pi over 6. So the way I'm going to approach that in this case is I'm going to draw sine of x in red, and then I'm going to shift that pi over 6 and draw that in green, and then I'll take that shifted sine of x function and draw cosecant. So bear with me, there's going to be a little bit of drawing and erasing happening, but it's the clearest way I can kind of get to the cosecant function is by drawing sine, and then a shifted sine, and then the cosecant that matches that shifted sine. So for sine of x, the amplitude is 1, period is 2 pi. So I'm going to break my x-axis up into 2 periods from 0 to 4 pi. And then the amplitude is 1, so I'm not going to put 1 at the very top or bottom because I want to leave room to draw my cosecant. So in red here, this is my sine function, just sine of x, 2 periods of that. And then if I want to shift that pi over 6, if each of my boxes, if every 2 boxes is pi over 2, that means each box is pi over 4. And if I want to shift it pi over 6 is slightly less than pi over 4. So I'm basically going to shift my x-intercepts and my mins and maxes to the right just less than 1 box on my axis. So I'm going to do that, and I'm going to draw that in green. So you'll see that there. I'm going to leave it dotted because it's not the actual function I want to draw, but that's the shifted version of my sine graph. So what I'm going to do is then erase the red one. You can leave it there. I just know that if I keep both of those functions and the cosecant and the asymptotes, it'll probably get a little hard to read. So that green graph I have now is my shifted cosecant function. My shifted sine function. And from that, I want to draw my cosecant of x minus pi over 6. So wherever this sine function crosses the x-axis, I'm going to draw a vertical asymptote. I'm going to do that in purple because I'm going to draw my whole cosecant function in purple. So there are my vertical asymptotes. And then where I'm just going to identify those x values first. So pi over 6, 7 pi over 6, 13 pi over 6, 19 pi over 6, and 25 pi over 6. So if I shifted 0 to pi over 6, and then from there I just added 6 to the numerator, because 6 over 6 is 1 pi. They're a pi apart. So then, draw my cosecant function just by using the minimums and maximums of my shifted sine function. And that purple graph that I have there, along with those purple vertical asymptotes, is the graph that I was asked to draw. So I took a sine function and shifted it, and then from that drew my cosecant function. So if I want to identify the x-intercepts, there aren't any. This would technically cross the y-axis just outside of the graph that I drew. It's not going to cross at a nice value, which is one of the reasons why I'm not going to identify it here. The asymptotes will occur at x equals pi over 6 and 7 pi over 6, those same x values that I identified before. So those are my x-intercepts of the 2 periods to the right of the y-axis that I drew. So hopefully that process makes sense. I think we might be able to go straight to the shifted sine graph if you wanted to. That's up to you. If you can do that, great. Just be careful that you're making sure you put your intercept or your intercepts of your sine function and your vertical asymptotes in the correct place. Otherwise, your graph will be off. So I'm going to approach it this way. I think for now it's definitely the most straightforward way we can go about it. And then the last function we want to draw is a shifted secant function. So what I'm going to draw is a cosine function in red, and then the shifted cosine function in green, so cosine of x plus 1. And then from that green function, I'm going to draw my secant of x plus 1. So if I want to draw cosine of x, the amplitude is 1, the period is 2 pi. So I'm going to break up my x-axis from 0 to 2 pi and from 2 pi to 4 pi. And then my y-axis from 1 to negative 1. I want to leave room for my secant graph. So if I just draw my cosine function, it will look something like this. So 0, 1, it would go through 2 full cycles up to 4 pi. And then if I want to shift that to the left 1, the way that I'm going to do that is if every box, if 4 boxes is pi, and that means every box is pi divided by 4, essentially. So every box is about like 0.78, give or take, which means I want to take every point that I have on my red cosine function and shift it to the left about 1 something boxes, 1 plus a little bit more. It's not going to be exactly on a grid line. One of the reasons is if my x-axis is broken in terms of pi and I'm shifting in something not pi, it's not going to work out nicely. So if every box, like I said, is about 0.78-ish, then I'm going to shift to the left like a little more than 1, less than 2 boxes. So I'm going to do that, shift the x-intercepts and the minimums and maximums to the left a little bit more than 1 box. So this green function I'm drawing here will be the shifted version of cosine of x, so this will be cosine of x plus 1. And then I'm going to erase the cosine part, so I'm just left with cosine of x plus 1 in green. And from that graph, I'm going to draw my secant function. So wherever this green graph touches the x-axis, I'm going to draw a vertical asymptote. And wherever there's a minimum or a maximum is where those U-shaped portions of secant are going to exist. Now I will say right now, at this point, the x-intercepts of this green graph are not that nice, which means the vertical asymptotes aren't at super nice x values. So I'm going to draw my secant portions, these U-shaped graphs here, and I'll show you kind of how I did that. So or how I identified the x-intercept. So there aren't any, or the x-intercepts of the cosine graph. There aren't any x-intercepts for the secant graph, but the asymptotes will occur where the x-intercepts of the cosine of x plus 1 were. So where are they? So if cosine of x crossed the x-axis at pi over 2, that means the shifted version would cross the x-axis at pi over 2 minus 1. There's really no nice way to write it other than that. It'd just be take pi over 2 and shift it to the left 1 unit. So that's how my vertical asymptotes are going to be identified. They're going to be in terms of pi over 2 or some multiple of pi over 2 minus 1. That's how I shift to the left 1. You could try and come up with a decimal approximation, but this would be probably a no calculator type problem. So pi over 2 minus 1 is the most direct and exact way to write that. So my vertical asymptotes would be at negative pi over 2 minus 1, pi over 2 minus 1, 3 pi over 2 minus 1, 5 pi over 2 minus 1, and 7 pi over 2 minus 1. And that's just because cosine crosses the x-axis at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So if I shift that to the left 1, that's how I would write those x-intercepts of the cosine function, which means that's how I would write the asymptotes of the secant function. Now you could see I accidentally wrote the asymptotes as coordinates, as intercepts. So actually the way they should be written is x equals negative pi over 2 minus 1. That's my first asymptote. And then my second one would be pi over 2 minus 1. And then my third one would be 3 pi over 2 minus 1, and then 5 pi over 2 minus 1, and 7 pi over 2 minus 1. So those are the vertical asymptotes of my secant function, which were the x-intercepts of my cosine function. So this kind of 3-function approach will be a pretty straightforward way of getting to secant and cosecant. It's not the only way, but it's the way that I'm going to approach it, just so we know kind of where this is coming from and building off the way we've been approaching graphing sine and cosine up to this point.